Hello friends, welcome to EMTECH channel. This is yet another video in this channel. In this video, we are going to see about how testing of electromechanical relay is carried out inside. We will show you live demo how the relay works. Before seeing that, it is important to know about the internal parts of the relay and its settings. Let's see one by one. In this video, we are going to see about IDMT or inverse definite minimum time relay or normal inverse relay. In this type of relay, the operating time is inversely proportional to the fault current. Out of three categories in the inverse definite minimum time relay, today we are going to see about standard inverse or normal inverse type electromechanical relay. Now we will see the internal parts. First is the time setting multiplier, next comes relay contacts, third is disk, and fourth is the plug setting multiplier, and then the current settings and CT secondary terminals, and finally relay NONC terminals. First we will see about the CT secondary terminals. This is where the secondary winding of the CT is connected to the relay, and based upon the current in this secondary terminals, relay will function. And you can see a simple schematic here, and the yellow line indicates the CT secondary terminals. Next, we will see about the relay NONC terminals. This is the output of the relay, and from this point, the supply to trip the breaker during the fault is sent. NONC contacts of the relay is connected to these terminals. And next comes relay NONC contacts. This is the NONC contacts which changes its position from NO to NC and NC to NO when the disk is actuated, and you can see this clearly in testing, which we will going to show now. And this is connected to NONC terminals. Next comes the disk. This is the heart of the electromechanical relay. This disk is an induction disk mostly made of aluminum and placed between the poles of the electromagnet, and it is held stationary by controlling torque. If the fault current reaches to a value called pickup value, the deflecting torque is produced and it increases the controlling torque. As the deflecting torque is increased, the disk will start to rotate, and the speed of the rotation and the distance of its rotation are based on PSM and TSM settings respectively. Disk acts as an actuator to trip the relay. And now we will see about three important settings which we should understand very well to get this desired relay operation. First is current setting. Current setting is also called as a plug setting, and this is used to adjust the pickup value, and the pickup value of the relay is the amount of current above which the disks will start to rotate. Current setting will be adjusted by changing the position of the plugs. You can see the plug here, it will be mostly of screw type. In this, if you see, there are 7 positions, and you can remove the plug from one setting and can be screwed into the another setting. The each positions will be incremented 25%, and the values start from 50% to 200% of the rated CT secondary. For example, if we want the relay to operate at 150% of the rated CT secondary, let's see how it's set. See, my rated CT secondary is 5 amps, and I want the relay to start operate when the fault current reaches to 150%. So the setting will be 150% of the rated secondary. What is rated secondary? You can see in the down right here, it is given as CT secondary 5 amps. Means if your rated CT secondary is 5 amps, you can use this relay. Now 150% of the rated secondary is 150% of 5 amps, that is 7.5. So you have to set the plug at 7.5. In this picture shown, the plug is set to 5, which means the relay will operate at 100% of the rated CT secondary. Now we will see another important setting called as a plug setting multiplier. It is defined as the ratio of the fault current to the pickup current. It defines how severe the fault is, and it decides how the speed of the disk should rotate in case of fault. For example, assume a CT of 1200/5 is connected to this relay, and a fault current of 2400 amps is flowing in the primary of the relay. So the secondary will receive 10 amps. If the current setting plug is set to 5, then the PSM will be 10/5, which is 2. And from the scale given in the relay, you can see the scale here. To the scale given here, we can know that for plug setting multiplier of 2, the relay will trip approximately at 4 seconds. Remember, this setting alone will not decide the operation time of the relay, and it is interdependent on the time setting multiplier also. In this case, if the time setting multiplier is set to 1, this is the time setting multiplier dial you can see over the top. Now it is set to 1, the relay will trip in 4 seconds. Next comes time setting multiplier. Next is the time setting multiplier. It is also called as TSM, and it is a setting that is used to adjust the traveling distance of the disk, and which in turn increases or decreases the operating time of the relay. The dial you can see here, it is the time setting dial, and it is calibrated from 0 to 1 in steps of 0.05 seconds, and the actual time of operation of the relay is time as per plug setting multiplier into time setting multiplier. And in our case, actual time of operation will be PSM equal to 2, so time is 4 seconds, then 4 seconds into time setting multiplier 1, so it will come around 4 seconds. So the relay will trip in 4 seconds. Suppose if TSM is set to 0.5, then what will happen? 4 seconds into 0.5, which comes around 2 seconds. Thus, varying the time setting multiplier dial will vary the time of operation of the relay. Now, we came to the testing part. The relay operates based on the current flowing in the CT secondary terminals. So we will inject the current in the CT secondary terminals and increase it over the pickup value, and we'll check how the relay responds. For injecting the current, we use a calibrated current injection kit, and the tripping time is checked. For example, if a CT of 200/5 is used in the line, injecting a current of 10 amps in the CT secondary will make the relay to operate as if 400 amps is flowing in the secondary, that is 200% of the rated current. This is the kit which we are going to use today for relay testing. This kit serves for two purposes, one for current control and second for voltage control. Now we are going to see current control only in this video. It consists of one digital ammeter, one digital voltmeter, and the voltmeter we are not going to use for this application, and a digital timer. A output on green button to inject the current into the circuit, and output of red button to cut off the supply. Different probes with different current ratings are given, and we can screw in our wire to our desired rating. This kit works on 230 volt AC supply, and from this kit we take two wires to the relay. You can see in this picture yellow and black wires that carry current to the relay. Actually, black wire is not seen now. During testing you can see the wire, and you can see, as said earlier, this is a current setting plug with 7 different positions, and we can screw in the plug to suit to our application. As we said, we connected the wires from the kit to the secondary terminals, and these 4 metal strips shown are the 2 NO contacts. Mostly it will be of NO contact. This particular relay has 2 NO contacts, one for tripping that will be connected to the trip coil of the circuit breaker, and another is for alarm indication. You can see the yellow and black wires comes from the kit. This acts as a CT secondary terminal, and you can also see rated secondary for relay is given as a 5 amps, and the current setting plug is screwed in 5 amps. And now connections are over. We will switch on the output on button. A predetermined current was previously set in the kit of 10 amps, and as seen, when we press the output on button after a delay, the relay trips. After pickup value reaches, disk starts rotating. The projected part causes the contacts to change over and causes a trip indication flag, and we can see in slow motion. So I conclude the video here. If you like the video, give a like, comment and share the video to your friends, and subscribe the channel by pressing the subscribe button, and also press the bell button next to it and select the option to all, so that you will be notified whenever I post a new video. Thank you. We'll meet you in next another interesting topic. Take care.